Okay, we have another problem here. So we have another heat cycle at this given inlet condition of the turbine. So 8 megapascals and 485 degrees Celsius. Expand to 1.4 megapascals. At this point, the steam is withdrawn, pass through the reheater. No? It re-enters the turbine at 1.3 megapascals and 720 degrees Celsius. Expansion occurs to the condenser pressure of 0.006 megapascals. So for the cycle, determine QA network and the efficiency of the cycle. Okay, so how do we solve this? No? We need to first draw the TS diagram. No? It is really important to visualize the problem. So you have here a TS diagram. Yes, it is not. Okay, so you have here your TS diagram, and so it is entering at 8 megapascals. So let's say this is your 8.0 megapascals, and then it is at 485 degrees Celsius. And then it is expanded. We don't know if it is saturated or superheated, no? So let's just assume that this is superheated. And this will be 1.4 megapascals, no? So it is up to this point, 1.4 megapascals. So the constant pressure line will be this, no? And actually, it is withdrawn, sorry, it re-enters the turbine at 1.3 MPa. So there is a pressure loss from the reheater into the next stage of the turbine. So therefore, the constant pressure line will be much lower, no? So this will be, as you can imagine, for example, this is about 1.3 megapascals. Actually, we should write this in red, no? So 1.3 megapascals, and it is around lower, no? Lower yung constant pressure. It is not, it is really hard to write this if it is this close, no? Pero make things a little bit closer pala, no? 1.3 MPa. So I'll just write 1.3. And the constant pressure line will be around, sorry, like this, no? So it will be somewhere a bit lower than the actual. So this will be your second expansion. And then you have a given temperature. It's actually higher, no? To 70 degrees Celsius. Is that right? That's actually right, no? So it should be actually higher than this, no? Yeah. Okay. And then it is expanded again into we don't know if it is saturated or in the superheated region, but we will assume that this is in the saturated region, no? So this will be 0.06 0.006 pala, no? Megapascals, no? And then you have here the saturated liquid and then the pump, and then it's over, no? So let me notate this again. So this is 1, 2, 3, 4, 5, and then B, no? So dito, there's a pressure drop from 2 to 3. So the outlet of 2, oh sorry, of this turbine from 1 to 2 is um is 1.4, but the inlet will be 1.3, no? So it is kind of different, no? Medyo kakaiba, no? Anyways, so to find the point 1, so for point 1, this is just 485 and degrees Celsius and 8 megapascal. So we can just check table 3. Table 3 lang. Okay, table 3. So 8.0 and 485. So we have to interpolate this, no? We need to interpolate this. So 8.0, no, it is not actually needed. 485, hindi, needed pala, no? 485, so for 480 and 490, we have here the temperature 480 and then 485 and 490. So 485 is not given, right? No? So you have here 3, 3. So for the H pala, no, sorry, I didn't try the H. 3, 3, 4, 8. for 8.4, tapos 3373.4. And then the S here, so S here is 6.6586 and then 6.6916. Ayan. So we want to find the H and the S, no? So using our calculator, we can find H and S, no? So H1 and S1 can be calculated, no? So you have here, again, mode 3.2 tayo, no? Mode 3.2. Mode 3.2, you have 480, no? 480, 490, 3348.4, and 3373.4, no? And then AC shift 155, then 485. So 3360.9, no? 3360.9. And then for the S, we can also solve for that one. We can just change, no? If you want, you can just change the data. So you can just change the data here. Just change this into S, no? So 6.6586 and 6.6916. Okay, so shift 155, 485. 6.6751. 6.6751, no? So ito yung interpolate natin. So this will be H1 and this will be S1. Okay? So we're done with H1 and S1. We now want to find H2 and S2. So we know that at point 2, S1 is equal to S2, which is equal to 6.6751, no? Okay. So in this the only given is the pressure 1.4 megapascals, no? So the pressure at point 2 is 1.4 megapascals. So what you can do here is you can actually check the table 2 if it is in the saturated region or in the superheated, no? So you can check table 2. So for table 2, 1.4 megapascals. So you can just check 1.4 and then check the SG. So 1.4 megapascals, the SG is 6.49 4693, no? So SG, ito yung maximum SG in the saturated region or the maximum entropy in the saturated region. Therefore, if this is less than 6.6751, then we are in the superheated region still. So we cannot use table 2, we cannot use table 3, we have to use the Mollier chart, no? So for the Mollier diagram, we can estimate the value of the enthalpy, no? So in here, it is actually hard to look at this, but we can estimate using this one, no? So we have, for the entropy, you have 6.6751. So this is 6.6, 6.7, 6.8, 6.9, no? So 6, 7, 8, 9. So 6.67, so around here, the middle, no? And then a little bit on the middle again. So around here, no, will be your line, no? I don't think I can write here, no? I'm not sure if I can write, no? So I'll just, let's just navigate through this middle of this grid here, no? So what we're looking for is 1.4 megapascal. So this is already in the in the megapascal scale. So we don't have even, no, we don't have 1.4. So it is actually hard. So in the middle is around 1.5. So ito yung 1.5, no? So ito, this is 1.2, 1.4, 1.6, 1.8. So actually this is 1.4 na pala, no? So this will be 1.4. And then we need to look at the 6.67 as well, no? So it is actually hard to look at this, but let's try, no? So this grid one, what I am looking at, and then you have 6.7, right? And then you 1.4. So the 1.4 here is, sorry, I'll just look at just looking at this. Okay. So this one, no? Around here. Is that right? Okay, 1.4. So this will be around 2950, no? Let me just check. 2950. Okay. Where's 1.4? Teka. Are we looking at the right? Ah, we are not looking at the right grid. We're looking at this grid. So this should be the grid. And then, sorry. This should be, ayan, ito. So around this portion will be your value, no? So, teka. Sorry. Nalito na naman ako. Ang hirap kasi pag hindi naka-PDF kasi tayo, no? Teka, 6.67. Ito pala dapat. 6.67. So, 6.67. Ito pala dapat yung grid. Ito yung longitude. Tapos, 1.4. 1.4. Ito pala. Ayan. This one. 6.67. So, ito. So, somewhere here, no, this point here, this is 1.4, no, this line here, and then this grid is 6.6, 6.7. So, 6.67. So, around here, no, this portion here will be your enthalpy, which is just above, a little bit to above of 2,850. So, we have around 28, we can just say 28 70, no, or 28 something, no. So we just estimate this as 2870, no? It's okay, no. So based on this, using Molar diagram, your enthalpy here is, let's say, 2870. Okay. Let me just check this again, no. Are we correct really? Kasi medyo off yung ano natin, no? 6.7. So 6.7 and then 1.4. Diba? 6.7. Actually, it is closer pala, no? It is closer to this line. So actually, this is about 2.9 na pala to, no? Mga 2.880. I mean, this is just an estimate anyway. So as long as you can pinpoint a near value, okay na yun. Oh, yun lang talaga yun. So this is about around 2.880 kilojoule per kilogram for H2. So we know the H2 already. Now to find the H3, okay, for H3, so this is on table 2 naman. So this is 720 degrees Celsius yan, and 1.3 MPa. So we can check again the steam table. So 720, where is it? So table 3, 1.3, 720. Okay, we need to interpolate again, no? So we don't have 720 here. So we need both H and S. So we need both H and S. So temperature is where is it? So temperature is 700 and 750. So 700, 720, 750. So the H here is 3921.4 and 3, sorry, it's actually 4036.6. And then for the S, we have 8.1507 and 8.2661, no? So yung H dito, guys, H dito, we just input this in on our stat, no? So let's input the values of the temperatures first. 700, 720, sorry, 750 lang. 3921.4 and 4036. Okay, so you see 720. So 3967.48. 3967.48. Yeah. And then for the S, so we can just manipulate the data here. You can just change this to S. No? So 8.1507 and 8.2661. So shift one, sorry, should be AC first, shift 155. So 720. So you have 8.199, 1969. 8.1969. So therefore, the thing that we can do, no, is use this entropy, no, for the expansion from 3 to 4. So again, this is H3 and this is S3, no. So for point 4, we know that S3 is equal to S4. So at point 4, we have S3 is equal to S4, which is 8.1969, no? And the other condition is the pressure, no, which is 0.06. So the pressure at point 4 is 0.006 megapascals, no? Um, we need to specify the HF and HFG and SF and SFG, no? So let's find the HF, HFG at table 2. Sorry. Oh, ito na. May sira yata tong ano ko, SFG. Ayan. Okay. So table 2, 0.006. Okay. So you have here 151.53, 151.53, and 2415.9. For SF, you have 0.521 and then 7.8094. Okay, so is this in the saturated region already? So we can see, we can look at SG. So SG here is 8.3304. But the SG, the S4 is 8.1969. So it is within the entropy, no? So this is in the wet region already, no, or the saturated region. So we can find the quality. Finding the quality, we can find the enthalpy, no? So S is equal to, so we have 8.1969 is equal to SF plus XSFG. So SF is 0.521, no? 521 yun, no? Okay, 521 plus X, and then yung SFG 7.0894. Okay, so yeah. So you can find the X here, X4, X4 tile. Yeah. Okay. And then using this quality, we can find H4. So HF is 151.53 plus X HFG. No? So X and HFG 2415.9. Okay, so X4 here will be uh what? No, sige. Wait natin. Okay, and then 7.0894. Ay, huh? What happened? Why is it greater than? Did we write, 08 pala, no? 08, 80 pala dapat. It should be less than 100%, no? So 98.29. 0.9829. Okay, so we can find H4. So using this, we have 151.53 plus the answer times 2415.9. So 2526, no? 2526.13, no? Kilojoule per kilogram. So we already got the H4. As for the H5, no? So for the H5 here, we need ano kailangan natin? HF4, no? So HF4, which is 151.53 only, no? What's next? So the pump work. So the pump work, we didn't get actually the VF, no? So I'll just write here the VF. So VF is 1.0064. 1.0064. Okay. Times 10 to the negative 3 cubic meter per kilogram yan. Oh, okay. So what's next? The pump work is just the specific volume multiplied by the differential pressure, no? So the differential pressure here is 8.0 megapascals, so 8,000 kPa, minus you have 6 kPa only, no? 6.006 MPa is 6 kPa. 660, okay, yes. No? So the pump work, okay, solve for the pump work. So 1.0064 raised times 10 raised to negative 3, 8,000 minus 6. No, so 8.045. 8.045 for the pump work. No? Okay, we're done with everything. No? So tapos na. Nakuha na natin lahat ng points. We don't need HB, no? Because we will just represent HB. We will represent HB as the pump work. No? Pump work plus yung ating H5. Okay? So, if you want to find the QA, sige, QA muna. So, for the QA, this is just the heat addition, no? So, itong 1 to B and 2 to 3, no? Actually, B to 1 and 2 to 3. Although we want to make things positive, so mas mataas yung enthalpy ni 1, so we have H1 minus HB, no? So, we want to make things, we want it to be positive, no? And then you have H3 minus H2. Yeah. So, we know that HB is just pump work and H5. So I'll just remove this. I'll write H5 and then minus pump work. Okay. So you can find QA here. And then I will solve for the network as well so that we will only calculate once. No? In a sequence na lang tayo mag-calculate. No? So the network is just the turbine work. No? So the turbine work here is the expansion from 1 to 2 and 3 to 4. So 1 to 2, so 1 and 2 plus 3 and minus H4. And then minus, syempre, the pump work. No? So minus the pump work, so minus pump work lang. Okay? And then for the efficiency, so since we already solved this one, so the efficiency is just network over QA. No? So we can solve this. Ayan. So H1 minus H5, H1 minus H5, so 3360.9 minus H5, so 151.53 plus H3, so 3967.48, no? 48 minus H2. So H2 is 2880. And then minus pump work pala to, no? 8.045. So we have 4228. 4288 pala. 4288. 4288.81, no? Kilojoule per kilogram. Okay. We're done with the heat added QA. For the network, we have H1 minus H2. So I'll just change this into H2. Actually, I'll change everything. So H1, sige, i-write na lang natin lahat, no? 60.9 minus H2. So 2880 plus H3. H3 natin dito, 3967.48 minus H4. So 2526.13 and then minus pump work, no? Minus 8.04. So we have 1914.2. 1914.2. Okay. So this is in kilojoules per kilogram. Okay, last one, the network. So we just have to divide this two. Okay. So the calculation, you have 1914.2 divided by 4288.81. So 44.63. So 44.63, no, percent. No? So as you can see, the calculation can be slightly off depending on usually the H2, no? If you use a Mollier chart, usually there are inaccuracies, no? Yung tinatawag na margin of error kasi um, we don't have an exact entropy line that we can write for 6.6751. We only have 6.6 and 6.7. So we just estimate this S here, no? And we cannot really pinpoint on the y-axis what is the enthalpy. Okay? So that's it. Thank you guys for listening.